Hi, I'm Mary Keenan, and I'm presenting my work on mercury concentration in Steller sea lion bones. I'm so excited to share my results with you today. I'd like to start off by asking if you remember what you were doing, say 25 years ago, or where you were living, or even what you were eating. How about 3 or 4 years ago? If you're anything like me, it might take you a few minutes to think about what you were doing that long ago. This is just some of the information that studying bone might be able to tell us. In humans, compact bone has a turnover rate of about 25 years, and spongy bone has a turnover rate of about 3 to 4 years. These turnover rates are assumed to be similar in other long-lived mammals such as Steller sea lions. In this study, my goal was to determine a consistent sampling location along the bone so that we can sample from the same location every time to get more comparable data. I analyzed mercury concentration in 7 different locations along the bone. You can see in Figure 1 and Figure 2, I used 3 proximal locations, 1 middle location, and 3 distal locations. Overall, from Figures 3 and 4, you can see that I found greater mercury concentrations and more variable mercury concentrations in spongy bone than in compact bone. So spongy bone is in the blue and compact is in the orange. I also found in adult bones that there were greater mercury concentrations in spongy bone at the proximal end, and there were greater mercury concentrations in compact bone at the distal end. In pups, mercury concentration in both the proximal and distal epiphyses were the highest. Overall, the middle point seemed to be the most consistent sampling point along the bone for both the pups and the adults. We also found really high variability in the proximal epiphysis in the adult bones, which led us to ask our next question about how the variability might change in different bones within the sea lion skeleton. Thank you for your time and consideration.